Okie dokie. All right, so if we take a look at number 26. All right, 26 said we want to solve and graph. So this is 3c plus 4 is greater than or equal to 13. Or, Jacob, do you have a question on this problem?
No.
Okay, go ahead. 6c minus 1 is less than 11. All right, so my first question for you is, did you write it down properly? Okay. So I'm going to start solving this. I'm going to add a negative 4 to both 13 and 4. And I end up with 3c is greater than or equal to 9. All right. Now I'm going to divide by 3. C is greater than 3. So here's my first one. Are you cool with that? Okay. I'm going to put or here. All right. So now I'm going to do adding the opposite. I'm going to add a 1 to both sides. Did you guys see the graphs for these? Okay, I'll show you the graphs for these. Okay, so I have 6c is less than 11. Nope, 12. I'm going to divide each side by 6, and c is less than 2. So are you cool with that? Okay. So now I'm going to graph both of these on the same graph. So right now, Victoria, I'm telling you, you did something wrong with your graphing. That's fine. But I do want to talk about what you're saying, because I do want to address that, what you came up with. Okay. So my c is going to be less than 2. So I have an open dot at 2. And it's everything to the left of 2. And then I have c is greater than or equal to 3, so I have a closed dot at 3, and I have everything to the right of 3. All right, so we need to see the graphs of 24 through 27, correct? All right, so let me show you those, just so you have them and you can correct them, and then I'll take more questions. So here are the graphs. 24 through 27. So correct your graphs, please. And then Victoria, once we're done correcting homework, when we get our notes out, I want to get back to that, okay? So remind me that. What other problems can I do from the homework? Blythe? 27. Who needs to see what's up there? All right, you're making sure that you're taking notes from what we're doing, right? Awesome. So remember, guys, if you're ever absent, you're still taking notes on any of the problems that we're doing. It'll help you when you do them. All right, who needs to see what's up there? All right, so let's take a look at 27. 27 said, I have 6 minus a, Blythe, I can already tell you what I think the problem might be, is less than 1, or 3a is greater than or equal to 12. So, Blythe, did you do adding the opposite on this? Okay, so I have 6 plus a negative a. If I rewrote that, Blythe, what is my coefficient of that a? It's a negative a. What's my coefficient? Pardon me? Nope. If this is a negative a, what's my coefficient of a negative a? What does that really mean, Serena? Yeah, so this is negative 1 times a, which is less than 1. All right, so now I'm going to add a negative 6 to both sides, and I have negative 1a is less than negative 5. And now I'm going to divide everything by negative 1, and I have a, I have to flip my inequality because my coefficient was negative, is greater than a positive 5. My guess is that's where your mistake may have gone wrong. Yeah. So on the other one, I'm going to divide each side by 3. It's a positive 3, so I don't flip the inequality. 12 divided by 3 is 4. So here are the two that I'm graphing on that graph. Are you cool with that? Are there any other ones you guys want me to do? Okay, get your notes out. We're going to do some story problems. And I also want to address something that Victoria brought up. Victoria, what did your tutor say? All right, so I want to tell you guys what Victoria and I were talking about so you guys can know what we're saying. All right, so what I want to do is today's the 20th. I want to practice compound inequalities. I want to practice compound inequalities. All right, I want to talk about ORs. Well, let's talk about the graphs. So let's talk about the graphs. All right, so when we have an OR and then we have AND. So I'm going to write typically. Typically this could be an AND, an OR inequality. So let's say I have, here's my 0. Let's say here's my -2. I have an open dot at -2, and it's everything to the left of -2. Let's do a 3. We have a open dot at 3, and it's everything to the right of 3. All right, if I was to write this, what would be the inequality for this side of my graph? So start with any variable that you want, and tell me what would the inequality of that left-hand side of the graph be? Matthew? Excellent, 2. Excellent. Or, Matthew, what would the other one look like? Excellent. So what does that mean the possibility for all my x's are? So all my x values are, how would you describe that? All my x values are, Colin? Greater than 3. Less than -2. Yep, excellent. Less than -2. How many of you guys would agree with him? Okay. Now, typically when we talk about an AND, all right, so I'm going to graph that one. So here's my -2. Here's my 0. Let's do a closed dot. And -2, let's do a closed dot at 2. They're going to be greater than that -2, smaller than that +2, so it's everything in there. Somebody write what that solution would look like. Somebody write what that solution would look like. Jacob? This is okay. Let's think about this for a second. Put your hand on. -2. Okay, so yep, so -2 is less than or equal to x, okay? Which is less than or equal to 2. Somebody explain that to me. All my x values are what? Troya? No, be specific. What does this say? It's not the average. Peter? We could say that. What's another way we could say that? Yeah, I would say something like are between -2. Oops, I'm going to put the number in there. -2 and 2, including both of them. Peter, I am going to write what you wrote because I think that's okay too. Or I could say all my x values are greater or equal to -2 and less than or equal to 2. Okay, are you guys cool with those? Yes? You guys cool with those? Okay. So I want you to tell me what this means. I'm going to flip, because I want to give you one that's kind of funky. But I want you to understand, I want you to use your knowledge of what ors are, or ands are, for you to say what the answer is, okay? Are you guys with me on this? Okay. Who needs to see what's up there? Okay, so let's say that I have a solution. Let's say my solution is x is greater than -1, or x is less than or equal to 2. All of you graph that. All of you graph that. How many of you guys are like, I need to make sure I wrote that right? Okay, somebody graph x is greater than -1 for me. Isabella? Okay, somebody graph x is, it says this is or. So all my x's are greater than -1, or they're less than or equal to 2. So somebody do that part for me. Ashton? How many of you guys see this? This is an or. So if you remember with an or, it means that all the x values meet one of the inequalities or the other. That's what an or means. So it either meets that qualification or it meets that qualification. So this is funky looking. So tell me, what are all my x values available? So if I was to explain this, all my x values are what are all my possible x values? Chris? Yeah.
But don't they intersect and like that?
They do intersect.
Well,
Well, that's a good question. Technically, ors can intersect. Typically, they don't. So usually what we're doing, we're going to see them going like this. All right? But it is possible for an or to go like that based on your data. So what does that mean all my possible x values are? Colin? Any number. It is any number. Because it has to meet all x values that are greater than -1, so anything going that way, or anything less than -2. So it really is any number. It is an unusual situation, but it is possible. So in this situation, it's all my x values, because every one of them is going to be in this shaded area or in that shaded area. How many of you guys see that? Kind of. I know it's funky, but it is possible. All right, let's look at a different one from there. Let's say that I have my x is less than -3 and x is greater than 0. All of you graph that. So these are just unusual situations. It can happen. So I need you to understand when it does happen, what our solutions actually mean. So what does x is less than negative 3 mean from a graphing perspective? What am I going to do? Jacob? Open circle. Excellent. All right, somebody, as soon as you guys see them walking around out there, take your garbage. You're going to quietly do this. Take your garbage, throw it in the garbage out here by the stairs, and you can go when you see them coming in. Okay. Jacob, go ahead and do the other one. The left or the right? The right. All right, so remember, this is an and. So let's talk about and inequalities. In and inequalities, what do I know my solution area has to be? In any and. Typically, what do and solutions mean typically from a graphing perspective? Charlotte? Yeah, because our graphs overlap. How many of you guys see that? All right, so for an and is the overlap of the two inequalities. So that's what an and means. So somebody tell me, what are all my possible values for my x? All my x values are, Peter? They have to meet both. So it has to be every number greater than, less than 0, and it has to be every number less than negative 3 and greater than 0. Are there any numbers that are less than negative 3 and greater than 0? Is there an overlap? Read this. Is there an overlap of these two graphs, these two shaded areas? Serena? No, there's no overlap. So what does that tell me about my x values? Are there any possible x values that would be a solution here? Charlotte? No. All my x values, I would say, I actually might write this, there are no x values. So it is not possible. Get out. Thank you, Grace, for reminding me. Just get out. Lord, help us all. Thank you for behaving and being quiet. I do appreciate it. Thank you. Okay. So these are two very different situations, but it's important for you to recognize what or means. It's all the x's that meet one of the qualifications or the other, and ands are all the x's that meet both qualifications. Okay, are you guys cool with that? Okay, so I want you guys to do a story problem. This is one of the ones from your 3.5 worksheet that I am not having you do. These are on this worksheet? Yeah. No, I don't like that. Okay, I'm going to give you one of these. Okay. Now, when we come to story problems, I need you guys to pay attention and make sure you remember this. So when we talk about story problems that are compound inequalities, first of all, they're all going to be ands. All right, and you're always going to write a general game plan where we have the minimum measure of whatever it is you're measuring is less than or equal to, depending on the story problem. So our general game plan, and you need to write this down every time because this is going to help you stay organized. Your minimum measure is less than or equal to your actual measure calculation which is less than or equal to the maximum measure. Yesterday we did some, I believe we did one that was the area of a rectangle, I think. We definitely did one that was the average. All right, so the minimum average, maximum average, the actual average equation that goes in here. All right, so if I had something like this, you may use calculators. I will let you use calculators for this. All right, so let's do an example. So let's say I have the, your mom and dad are building a swimming pool in your backyard. All right, so your mom and dad are building a swimming pool in your backyard. The area of the pool will be between 1,000 square feet and 2,000 square feet. I have no idea if that's really big or not big. It's a rectangular shape. All right. If the width of, let's say the length, if the length of the pool has to be 40 feet, what are the possible lengths or widths? I want you to set up an inequality to solve this. All right, I want you setting up an inequality to solve this. Okay, so let's take a look at this. What is the minimum and maximum measurement that we have? Come on, you guys. I need more than just 3 people. Read through this and identify what is the minimum and maximum measurement that I have given you. Matthew? So it's area, right? So I have a minimum and maximum area. All right, so this is a min and max area. So I know that's what I'm measuring is the area. Are you guys good with that? Okay, so I'm going to go ahead and just set up my general game plan. I have the min area is less than or equal to my actual area, which is less than or equal to my max area. So that is my general game plan. You're all writing that down. Now, I need to put in here the formula for area. How do I find the area of a rectangle? Peter? So I'm going to put in here that formula of length times width, because that's how I find my actual area. Are you guys good with that? That's the hardest part, is figuring out what to put in there. So since this is actual area, area equals length times width, so that's what I'm putting in there. Okay, let's fill in our numbers. Somebody write my inequality here for me with my numbers. Chris? Is less than or equal to? Well, I can't put x. I have length times width. Do I know either one of those? What's my length? So 40, and we don't know width, so that's going to be my w, right? So 40 times w. I substituted in the values I know into our area of my rectangle formula. Is less than or equal to what, Chris? Excellent. The hardest part of this is figuring out what formula to put in the middle, which is why I really want you focusing on, okay, what is my general game plan? I have my minimum and maximum area of my rectangle. So that means the formula for the area of the rectangle has to go in the middle. If I had a minimum and maximum area of a triangle, then the formula for the area of a triangle is going to go in the middle. Raise your hand if you're okay with what I'm talking about. All right, so now solve it. All right, I'll do this math for you. All right, so I have 1,000 divided by 40 is going to give me 25. So I have 25 is less than or equal to W, which is less than or equal to 50. All right, so my possible widths are between 25 and 50 feet. Yes. That's a good question. Technically, since I'm saying that it's equal to as well, we should see the word inclusive. So I do agree with that. So I'm going to say inclusive. Now the one thing, Colin, what I should probably do is I should probably go back up into my description and write inclusive in there too, since I put an equal to, right? So inclusive. If it didn't say inclusive, then technically this should just be a less than, right? Less than symbols. It's a very good point. And yes, I need to make sure that I write that, because somehow I have to indicate that it includes those numbers. So that's a very good point. These formulas are exactly the same for every single one of them. You just have to figure out what is it that I have the minimum and the maximum of. It could be I give you the minimum temperature in Michigan in February is 4 degrees Fahrenheit. The maximum is 37 degrees Fahrenheit. What are my possible degrees Celsius? I have my degrees Fahrenheit measurement, so the formula for degrees Fahrenheit would go in the middle there, right? And then the Celsius is the variable that's in there. Does that make sense to you guys? All right, so these are a little harder, but I always write that general game plan. You guys good? Okay, you guys can boogie.